Hello, my name is Allie, and I am the SI instructor for Chem 140 at Cal State Long Beach. Chem 140 is chemistry for nursing majors. So if you're not in Chem 140 at Cal State Long Beach, I do not recommend watching this video because the rules that they learn are slightly modified from real ochem rules. So I don't want to confuse you. However, if you are in Chem 140, it might be beneficial because it's hard to find specifically tailored videos to you. So today we're going to talk about aldehydes. We're going to talk about naming them, and we're going to talk about some reactions with aldehydes. And you can also see the video on alcohols, because aldehydes can be reduced into alcohols. So the alcohols video shows oxidation into aldehydes. Alright, so an aldehyde looks like this. Or it looks like this. This is the same structure. This guy looks a little naked. It's just like nothing. It just kind of stops. But there's an H there, right? Because you know that there must be, since this is a carbon, and there are 3 bonds, so the 4th one must be the hydrogen. So this is what an aldehyde looks like. And if we were to name this structure, we were to name this an IUPAC, we would say that this is F and now. In common nomenclature, we would call this acetal, because as a reminder, our prefixes for common names, 1 carbon equals form, 2 carbons equals acid, 3 carbons is propion, and 4 carbons is butyric. So there are 2 carbons here, therefore it's acid. Oh, we're actually going to say acetaldehyde. My bad. Because for common nomenclature, what you do is you just put the word aldehyde. Yeah, that's pretty much it. Acetaldehyde. Let's do another example. What if we did let's go ahead and name this common nomenclature and IUPAC. So first we'll do IUPAC. Why don't you try this on your own, pause the video, and try naming this on your own. Now that you have tried this on your own, this is always carbon number 1. The carbonyl carbon is always carbon number 1. So there are 3 carbons. So IUPAC would be prop and nal. The common name would be 3 carbons is propion. So we would say it would be propionaldehyde. We don't need to say carbon 1 because you always know carbon 1 is always the aldehyde carbon. It's always the carbonyl carbon that makes it the aldehyde. In your class, you're not going to be mixing aldehydes and carboxylic acids in the same molecule, so it's not really going to get too much crazier than that. Let's do another example. Why don't we something a little more complex? Have you try on your own? We'll do this and go ahead and try naming this guy on your own. Now that you have named this on your own, good job. Well, I won't say good job. I don't know if you got it right or not. We'll find out. IUPAC name for this. Let's see how many carbons there are. We see an OH, and we're like, oh, dude, that's an alcohol. Nah, bro. Aldehydes get a higher priority. So this is 1, 2, 3, 4, 5, 6, 7, 8. So the ending would be octanal. All right. carbon 4, there's a methyl. On carbon 5, there's a dimethyl. And then carbon 7, if an OH is a substituent, it's called hydroxy. Now, when you are doing this, since you have 3 total methyl groups in your structure, we are going to say that the methyls is 4,5,5 trimethyl. When you are putting in order of alphabet, you are not looking at this. You're looking at the M for methyl. You're ignoring the mono, di, tri. Well, it's not going to ever be mono, but you're going to ignore di, tri, etc. for putting in alphabetical order. So what this is going to look like now is it's going to be 7-hydroxy, 4,5,5 trimethyl octanol. And that's how we name this structure. Now let's go ahead and take a look at oxidation of aldehydes. I'm sorry, not oxidation. You oxidize alcohols into aldehydes. We're going to talk about reduction of aldehydes. Reduction of aldehydes. Let's take this aldehyde. Same one, why not? And in your class, you just say general reduction. You might see plus H2O as a reactant. And so if you reduce this, what you're going to get is, for this problem, we're going to assume that the alcohol isn't what's being reduced. Also, when you do reduction of an alcohol, you guys learn it as dehydration. You don't learn it in terms of reducing, but it is like the same thing. But so the only thing that's going to happen is you're just going to look at this part right here. The OH isn't going to do anything. Okay. And if that doesn't make sense, don't worry about it. Just know that the aldehyde was being reduced. Okay. So what you're doing now is you're turning this into an alcohol. So if I always tell my students, think of water as HOH. Hope. Right? Because water is made of an H plus and an OH minus. So what you want to do is just draw the same structure again. Draw the same structure for the most part. Draw the OH again, draw our methyl group over here, draw our dimethyl up here, but now you have an OH. And what kind of alcohol is this? Primary, secondary, or tertiary? If you watch the alcohols video, you'd be like, oh yeah bro, you oxidize primary alcohols into aldehydes, so you must reduce an aldehyde into a primary alcohol. So this is now a primary alcohol at this location. This structure is a little bit funky. It's, I'll say fun, because you actually have a diol now. You made a diol because there's already an OH over here. Let's go ahead and name this guy then. So the longest chain is 8, and since it is a diol, the way you do diols is you say octane, like the alkane, and then you say diol, and you have to specify what carbon numbers the 2 OH groups are on. So it's on carbon 1 and 7. So we're going to say 1, 7, octane diol. This is not what you do in real ochem. This is like a modified IUPAC, because this, we can only name this an IUPAC. First of all, we don't even have prefixes that go up to 8, so we can't even do that. Okay. 4,5,5-trimethyl. And that's it. 4,5,5-trimethyl. We'll squish there. 4,5,5-trimethyl -1,7-octane diol. And you'll notice that the name for this is a little bit different than the name for the other structure. Mostly because this is a diol now, so you changed a little bit more about it. Let's take a look at that. And that's pretty much it. That's kind of all you need to really know about aldehydes.